the 59-inch mill modernization project background. I'm going to be showing a short video right now produced by Bethlehem Steel about the project, and then I will introduce our speakers.
Manhattan, turn of the century. Most experts believe the skyline was about as high as it could go. But in 1907, Charles Schwab, founder of Bethlehem Steel, bought a license from Henry Gray that enabled Bethlehem to produce solid-piece, wide-flange beams. The mill was on stream in 1908. Orders rolled in, beams rolled out, and the face of the nation began to change.
Gray mill was a wide flange beam mill, which basically rolls, for simplicity, an H type of a beam or an I type of a beam. And in the early part of American history, they did not roll this as one piece. They used to take a plate and weld 4 angles on each corner to make the H or the I. And it was all was riveted together. You've probably heard the stories about Rosie the Riveter, because they would have to drill all the holes and then put all these hot rivets in order to make an H-beam. And then these were obviously used in buildings primarily. But the buildings could not be built as high because of all the rivets and the basically fabricated pieces. So there was kind of a limit as to the height of the building should have.
Actually, the first Gray mill was installed in Europe, but the first one in the United States was R48. And what it did was radically reduce the cost and make available to the construction industry a new profile of hot-rolled product that really aided the whole industrial revolution from a structural building standpoint.
The 1907 Gray mill remains in place today, but a recent modernization program gave it a facelift. A computerized, state-of-the-art roughing mill was added. The new 59-inch mill will give Bethlehem the most consistent, dimensionally exact product with the highest quality in today's structural steel market.
The Bethlehem plant, similarly to the Bethlehem Corporation, has 3 key goals. And our key goals are improvement of product quality, improvement of customer service, and a reduction of cost. The new 59-inch mill allows us an opportunity to attack each one of those areas. In terms of improvement of quality, it gives us the ability to make a section that is closer to the tolerance of the customer. In terms of customer service, it gives us a tool to allow us to meet the customer's ship-by date more readily than we may have met it before. And in terms of cost reduction, it allows us an ability to help reduce some of our cost of production. So the new mill in itself is a tool that allows us, the people of the Bethlehem plant, an opportunity to attack 3 of the key goals that we have established: customer service improvement, quality improvement, and cost reduction.
I think mainly we're going to be seeing an improvement in the configurational and dimensional quality characteristics of the product, more from the standpoint of reduced variability than anything else. One of the big gains we hope to make is a reduction in our weight per foot variability, and have weight per foot much closer to our specified aims.
Quality-wise, we get what we want. We are not subject to changes without knowing it. We have what we want. We measure a sample, we could adjust the mill, and it's going to stay there.
The 59-inch mill is a modern mill that's electrified, and it's a much bigger and sturdy mill with all kinds of modern features on it for speeding up roll change, for getting better dimensional control of the bar. It's a much more precise instrument than the old 48-inch mill rougher was. So we expect to see much better dimensional control over the bars by running them through the new mill. In addition, the new mill, after we learn how to use it, will enable us to take some passes off the finisher. In fact, we've already started doing that. And the finisher was an older 1908 mill. We'd be able to run the bar through with fewer passes there and less stress and strain on the old mill. Similarly, we may be able to, in the future, be able to take some passes off the older bloomer so that the 59-inch mill takes a bigger load of the 3 stands.
The real motivation for us putting the mill in is for quality. That was the original motivation, and in fact, we're seeing that it is delivering a much better quality product. But I think overall, from a plant standpoint, it's going to affect just about every facet of our business. That's going to affect our productivity and our costs, our energy consumption, our service, and it's going to make us more competitive.
In today's market, being more competitive is a necessity, and Bethlehem plant employees are well aware of the competition. That's why training for the new mill was a top priority. In fact, the new mill was installed offline long before actual operation was to begin. The purpose? Hands-on training for everyone, without losing valuable production time.
The reason to bring in a new mill, put it into an offline position, and move it over was to afford us an opportunity to do better training, afford us an opportunity to learn how the new mill operates, correct the mistakes, whatever we find offline, to allow us minimal disruptions to our customer and to allow us to bring that mill online for production at a shorter time span than if we would have just brought a mill on without the training, without the offline knowledge that we gained.
After the offline training was completed, the 450-ton complex was moved 300 feet across the mill building into its permanent location. The offline training paid off. The first structural products began rolling on the new 59-inch mill in less than 3 weeks. Plant employees were very pleased with the minimal amount of lost production time, but our customers were even happier.
Our customers are very happy with our startup. And I think one of the biggest concerns they had was that here we are taking 50% of our capacity down and really shutting it down and hoping that when we put the new mill in, the whole thing will come up in a reasonable amount of time so that they won't have to go to other suppliers, because they have long-term ties with us, and at this point with a very strong market, it's difficult for them to get steel from other suppliers. So I think their big concern was availability, and our startup has really given them a little bit of a breath of relief, because we're pretty much on target for what we said we would do in the startup phase, and they're very happy. The feedback is very positive.
Preparing, installing, and operating the modernized mill was a difficult task, but Bethlehem employees were up and ready.
They're really up about it. I think everybody is up about it and has a right to be. I think it's a real tribute right from the very start that when we started the mill up, we did not have any significant reduction in quality or any quality problems compared to what we had prior to pulling out the old mill. It tells a lot about the attitudes and the planning and the training of everybody involved that we could start the new mill up and come out running.
The attitudes, the energy, the willingness to participate in a team effort was never more identified as it was on our 59-inch mill installation startup. Our Partners for Progress program worked to the nth degree in the cooperation and the spirit of our 59-inch mill startup, and that's what's made it the success it has been.
The new 59-inch mill, what it means about the plant, it means life. It's breathing life into the plant again. It means employment. It means, I think, a future for the younger generation.
our philosophy is such that there's nothing can't be improved on. I don't care if it came from 1907 or 1990. It can be improved on, and we are constantly trying to do one bit more than we did before. And that's what keeps you alive and well.
I think we've set harder standards for ourselves on the quality, where we're trying to perfect. People were worried, well, we got a new mill, we wouldn't continually try to improve the quality. I think the opposite is true. We take it and we reach a new level of quality, but they keep trying to make it better, trying to, what we call, roll the trophy bars. We had a shift last night of HB 12 where the centers basically stayed the same for the whole shift, which under the old mill, we could probably work the whole shift and continually making moves all the time, and it was still saleable, but we didn't have the degree of stability we now have with the new mill. And I think the people are believers now, they definitely are. You hear all the doom and gloom in the structural market, but this is like the Alamo, and I guess I'm Davy Crockett. And they're going to be fierce fighters. We're on the offense now, instead of the doom and gloom defense. We're on the offense, and I think our people are going to show that.
The Old Gray Mill, a tribute to Henry Gray, who planned and worked for years to make his dream turn into a reality. The new 59-inch mill, a tribute to the people at the Bethlehem plant who believed it could work and made it happen in record time. Combining the old and the new has made the Gray Mill more competitive. It will give Bethlehem an edge in the structural steel market of the future.
From one of our archival volunteers, Joel Hoffner, a couple years ago, that I can't believe you have this, you need to talk to Larry. And so we were able to, after a couple of years of coordinating, going back and forth and reassembling the model, I'm very happy to have him here today. He's a lifelong resident of Bethlehem. He's a 1966 graduate of Bethlehem High School and a 1970 Lehigh University grad with a BS in electrical engineering. He joined the Bethlehem Loop course during the summer of 1970. Larry was assigned to the Bethlehem plant, initially in the electrical department as an electrical engineer and subsequently in plant engineering as a senior project engineer. Primarily associated with a number of capital projects, the list goes on, including a coke oven battery, blast furnace cast house emission control, blast furnace C&D rebuilds, British Steel joint venture, the 40 #1 Bloomer electrification, where he served as project manager. He served as project manager for the 59-inch mill project, the combination mill modernization project, project manager, hot dip galvanizing lines at Sparrows Point, and Burns Harbor as automation project manager, ladle desulfurization at Burns Harbor, senior project manager, at Sparrows Point Cold Mill, senior project manager. In 2000, Larry left Bethlehem Steel with 30 years of service, and he joined U.S. offices of F.L. Smith, a Danish engineering and manufacturing company specializing in mining and minerals processing. He retired in 2015 as manager of global operations. And we'll speak with Larry in a moment. Mike Zaia will be talking with us first. He's going to start us off with some background on the 48-inch mill and Henry Gray and Charlie Schwab. And Mike is a 61 graduate of Allentown Central Catholic. He received his degree in electrical engineering at Villanova University, graduating in 1965. He was a baseball player, and although he was offered a contract by the Philadelphia Phillies, he signed with Bethlehem Steel because it was $20 extra a month. $620 versus $600. A 65 looper, Mike joined electrical engineering at the Bethlehem plant, and then he worked at Saucon maintenance for about 15 years, becoming superintendent of Saucon maintenance. In 1984, he was transferred to the Steelton plant as maintenance manager and then became the VP of operations there in 1988. Transferred back to the Bethlehem plant, VP of operations here in 92. Then in 94, he was named president of the Bethlehem Steel Corporation subsidiary railroads companies, and he was responsible for starting Beth Intermodal operations, and he worked for Bethlehem until 2002. He's currently a partner at Lehigh Valley Rail Management, which operates the short line railroad here in Bethlehem and at Johnstown. So we will welcome Mike, and Larry will be next.
As Andrea said, I'm going to talk about Henry Gray, Charlie Schwab, and the 48-inch mill. Henry Gray was born in England in 1849, came to the States about 20 years later, worked in the iron and steel business, mainly in Ohio, and toward the end of his career, late 1800s, early 1900s, developed this idea for rolling wide flange beams. And he patented this idea. And what it was, this is a small beam that I can hold. I used to lift the other one over here. I can't handle that one anymore. So Henry Gray's idea was to roll all parts of the beam at the same time. So the horizontal rolls would roll the web, the inside of the flanges. The vertical rolls would roll the outside of the flanges. And there were edging mill rolls that would roll on the toes of the flanges, all at the same time. Well, that's about the same time that Charlie Schwab comes into the picture. Charles Schwab comes into the picture. He's president of U.S. Steel. He hears about Henry Gray's patent. He thinks it could be a game changer. So he talks to the folks at U.S. Steel. They're not interested, nor any of the other large steel companies at that time. And Charlie Schwab was a risk taker. And he had lots of, maybe not lots of, but some disagreements with the folks at U.S. Steel. He left U.S. Steel in 1903, bought the Bethlehem plant and some shipbuilding assets. So while he's at Bethlehem, he never forgot about Henry Gray and his patent. He inquired about the patent and found out that Henry Gray had licensed the mill in Luxembourg to roll wide flange beams. Charles Schwab went to Luxembourg to see for himself, and immediately he thought, this is a game changer. And as they say, the rest was history as far as the Bethlehem Steel Plant and the corporation goes. Schwab came back to the U.S., bought the patent, built a 48-inch mill. And I'm going to talk a little bit about the 48-inch mill. In 1907, 1908, the 48-inch mill starts up. The 48-inch mill was a heavy section mill. So it rolled beams. That was a 59-inch mill beam, but it rolled beams very similar to that. They were called W36. The W36A, 3 feet wide, was 300 pounds per foot. They rolled column sections, and there's an example outside the room here when you come in of a W14E, which is 398 pounds per foot. That's kind of a little sister, if you will, to the heaviest beam that they rolled, which was a W14G, 730 pounds per foot, if you can imagine that. I couldn't lift that one up anymore either. I'm going to explain a little bit about the 48-inch mill, because it gets very confusing. When we talk about the 48-inch mill, we had a blooming mill, we had an intermediate mill, we had a finishing mill. So people get confused when you hear the word mill. What the mill? Well, the mill is all of that. But in my mind, the hierarchy is the gray mill process was just a way, a brand new invention, the way of rolling wide flange beams. Now underneath the topic of the grain mill, you have the 48-inch mill, which is a heavy section mill. You had the 42-inch mill, which started up around 1920, was a medium section mill. And then you have, in the 48-inch mill, under that category, we have a blooming mill, which has to break down the ingots that come from the Saucon pits. And you have another mill called the 48 number 1 mill, which was an intermediate mill which finished the blanks pretty close to a finished dimension. And then you had the 48 number 2 mill, which would finish the beam entirely. So I understand if you're confused as to what is a mill. It's all of the above. The material process flow in the mills from west to east. All the mills in the Saucon mills rolled west to east. The mill building that housed all of this was huge, a couple football fields long, probably stretched from here up to the skating rink. Both the 48 and the 42-inch mill were parallel to each other, maybe separated by 75 feet or so. So the ingots were in the soaking pits, from 5-ton to about 20-ton ingots, depending upon the section and the weight that you're going to roll. The ingot would be transported to the blooming mill, and the blooming mill would take up to about 30 passes. It's a reversing mill, so almost ladies, like you're rolling dough, you know, with a rolling pin. It's kind of similar to that, where each time you make a pass, they lower the top roll to put a little more pressure on the beam, on the ingot, and it will elongate that ingot into a beam blank shape by the end of these so many passes. The beam blank would transfer via roller line, roller table, to the 48 number 1, take up to about 17 reversing passes there. Same thing, squeeze it a little bit more with each pass, elongate the bar, and you probably finish, depending again upon the weight, 35 to 75 feet long out of here. Go down to number 2 mill, take maybe up to 11 passes. In the new setup, when you had the 59, you didn't have to take that many passes at the number 2 mill. So we take about 11 passes there, come out with a finished product according to what the customer ordered. Take it down to the hot saw, cut the front end off, cut the rest of the beam at certain lengths, and it would then go down to the shipping facility and be straightened, be cut at the cold saw to customer length, and then put on a truck or a rail car. It wasn't unusual for us to load 200 trucks a day and 200 rail cars a day. At that time, in the heyday of the Bethlehem plant, as we got into the 30, 40, 50, 60s, we used to ship over 2 million tons a year of structural steel, and 50% of that or more came from a 48-inch mill. Just a couple of other tidbits. These mills were run by steam engine power. These steam engines were huge. The 48-inch mill steam engine would barely fit in this museum. It was so big. The rumor when I worked down there was the steam engines came off the warships from the Spanish-American War. Was not true. They were made by William Todd in Youngstown, Ohio. The other thing I want to mention is a lot of people ask, how did the 48-inch mill get the name 48-inch mill? The number corresponds to the diameter of the drive pinions for the 48 number 1 and 48 number 2. There's a set sitting out here on the patio. If you have a tape and you want to measure it, they're 4 feet in diameter. 42-inch mill, 42 inches in diameter. 32-inch mill, 32 inches in diameter. Before we get to Larry, who's our star speaker today, I just want to mention that people that work down there in the operating department and maintenance departments were the best. They were a significant part of Bethlehem Steel's success in the structural business marketplace, and they held that spot for a long, long time. Okay, so we'll go to Larry, and if you have any questions, we'll try and answer them, and we have enough other experts in here that can help us. Larry. Right.
Okay, thank you, Mike. Just a couple of notes on the Andrea's comments at the beginning here. I just like looking around here. Are there any Bethlehem High alumni in the audience besides myself? All right, there's Jerry. Jerry and I graduated. Oh, good, okay. I'm Liberty High, Bethlehem High, back in the 60s. And number 2, she gave me credit for finding this film that you watched earlier, and I have to admit that one afternoon, not too long ago, after searching through the archives in the warehouse and here, my wife was rummaging around in my son's old bedroom while looking at his old high school sports tapes and found that tape. Wow. So I got to give her credit for that, and we all do. Okay, most of my comments here are going to be a commercial for Bethlehem Steel, Bethlehem Plant Steel Workers. And by steel workers, I include the whole gamut. We had from some of the management people that you see on the screen there, to all of our engineers and our welders and our carpenters and our riggers, and our mill maintenance people and our mill operators. You heard Chico Kersey mention the cooperation amongst the plant for the motivation to be successful with this mill, and you heard some young fellow on there talk about the Partners for Progress, and that program was just a handshake, basically a handshake agreement between our union construction crafts and our engineering and construction management, that we said, let's go do this and let's go do it right. And I'm going to take another few minutes to just give you an idea of how certain things evolved from that discussion and from that agreement that let's just do it right. We all remember Mike Tyson, the great sage, who said everybody's got a plan until they get punched in the nose. Well, we recognized right on that we're going to get punched in the nose a few times when we try to put this mill in place and try to do it to meet the goals that our operating people and our management gave us. We could not suffer a months or weeks or months long protracted startup schedule, or we would be frankly lost our customers. Jack Kinsey mentioned that customers were saying, "Hey, good luck, but if you can't meet your obligations to us, we're going somewhere else because we've got our own customers to deal with." So that was our real focus, is we had to find a way to put this mill in without putting us out of business, simply stated. So we started thinking some things right off the bat and how we could do some things to eliminate or to prepare for the times that we'd get punched in the nose. One of the first things we decided is maybe it wouldn't be a bad idea if we built this mill in plastic before we built it in steel. And we got a chance to prove out our designs. We got a chance to see what this thing looked like and how we might be able to fit it in the easiest way on existing mill foundations or did we need to bury the foundations there, or remove the foundations and put new ones in? So we thought let's build a mill, a model. What you see here is the result of that. It's from the Bethlehem Pattern and Model Shop in West Bethlehem back in the 1980s. Cliff Lynn was the proprietor of that shop. I don't know if anybody remembers that name or the mill, the shop. We took it a step further. Since the drawings were built in 1-inch to 12-inch scale, we said, let's build this model in 1-inch to 12-inch scale. And it just happened that that scale fit what you see here. It was a little bit portable, yet it was big enough that we could do what we needed to do, and then we could use it in our engineering, the confirmation of our engineering designs. And that's what we did. Andre, I'm not sure how much time we have in the room here, but afterwards, feel free to come up and enjoy the mill, the model, play with it, look at it, do what you want with it. Since it's 30-some years old, we'll take away the do not touch sign, and we'll say, let's play with it, okay, if you want. So we built this model to 1/12-inch scale, and we thought, is that going to have us any other benefits besides just proving out our designs? And as it turned out, we decided that, we noticed that since the detail was right at the same level as our drawings, we could look at the mill and we could look at all the components that we need to fasten onto the mechanics, the piping, the electrics, the instrumentation, the actual drives. So we could actually put those all together, and we could fit them in here since we knew what the mill configuration looked like in 3D. If you're familiar with any type of mill construction here, with all the piping and the wiring that's associated with the on-stand instrumentation, you can't do it from a drawing. You can get close, you can get an idea, but you can't do it from a drawing. You have to have something physical to prove the routes. Well, we had the physicals to prove the routes. So a lot of the fit and field work that we needed to do during the shutdown, we had a leg up where we had to plan it better by the use of the model. Then one day we had a discussion amongst ourselves, and we said, hey, what if we pick the damn thing up, we build it somewhere else, pick it up and move it over and put it on in place. Maybe we could save some installation time. And then after maybe a week or so of thinking about that and a few Manhattans off time, we got together and said, hey, you know, that's not such a bad idea. There's some possibilities there. We knew we could build a mill. You have to build a mill anyway. We knew that those hurdles we could get over. But if we built it, how do we move it? Well, we found a company in New Jersey, the F.W. Haight Company, whose specialty was moving mechanical equipment. And long story short, he came in and looked at the mill and actually picked up these housings in one piece, put braces between them in plastic and in wood and what have you, and he rigged a configuration where he said, I can pick it up if I can lift it. How much does it weigh? And we said it looked like it's going to weigh around 410 pounds, 410 tons. Turned out to be 450 tons. And he said, you know, I have a gantry crane in my yard that's rated at 600 tons. Well, the Manhattans we had that night tasted a little bit better than the ones we had when we thought we might be smoking dope here with lifting this mill. That was really the lightning rod that gave us an opportunity to put this mill together offline and take advantage of the work we could do while we were still making product on a 48-inch mill. You know, if sometimes a good idea turns into a not so great, and sometimes it turns into, wow, look at what we could do now. Besides putting all the in-place piping and conduit and what have you on the mill, we said, why don't we wire it? Why don't we pipe it up? And connect the mill to manifolds of electrics and hydraulics and water, what have you, that we would put in an offline position and test all the components. I said, well, why don't we run the motor leads and we can test the motors? And God bless our technology and our mill engineers and with their rolling expertise. And they said, well, why don't we roll? Okay, sure. Process we call it ghost rolling, where we actually wired and piped the whole mill, hydraulics and electrics, tied them back into the motor rooms, which were behind the motors, right behind me, tied the motors into the offline facility, and we would ghost roll, where we would set the mill up for first pass, and we would fake the bars going through, and have the mill go through its sequencing from first pass to last pass, eject the bars down to the next mill, and set itself up again for first pass. We did that for maybe 2 months after we installed the mill offline. So that gave us the opportunity while we were doing the ghost rolling, is we built the gantry crane from Hake and got ourselves prepared to move the mill. When I say move the mill, as you can see, the darker plastic here is the existing feed wall table. Everything that's in lighter plastic is part of the new mill. What we lifted was everything basically from here to here in one piece. Okay, there are 2 complete mill stands: the edger mill and the finishing mill. The roll change rig, as you can see when if you get up to play with it, it's a bunch of little pieces. There's no way to put that together in a way that we could make a bigger lift. That was little pieces that we had to put up anyway. We had to pick up any way we could. While we were obviously before we did that, the 10,000 horsepower motor was installed. The 4,000 horsepower engine motor was installed. The 59-inch pinion stand on the main mill and the smaller pinion stand on the edger mill were all installed and tested. They were all ready to go prior to during the period while we were ghost rolling on the other side of the mill. And I failed to mention that, and I'll just add another comment here. When I say sometimes being lucky and good, or an idea turns into a better idea just by chance. When we talk to most of the mills in the country, most of the mills in the world are built in an inline fashion. In other words, they're in a building that goes from the blooming mill, the 32-inch mill, down to boom storage, and maybe to this part here where the building runs this way. The 48-inch mill, the building ran this way, and then this way at the 48 number 1, and then continued in another building down here, which gave us the opportunity to have this area here, just above the mill on this drawing here, to install the offline piece, which you saw in the video when you saw that big crane, the gantry crane with the mill suspended. It was over here, and the mill did it this way. Okay. 18 days, 36 shifts, from the last bar to the first bar on the 48-inch mill. Our operators, our management, they gave us 3 weeks. They gave us 21 days. 18 days from bar to bar when we put the new mill in place. The first bar we rolled, obviously it was 2-section and 2-weight. There was a conversation from then till now, whether it was a W12 or a W16. There's a difference of opinion here between the fellows that we had working back then and our memories after 30-some years. First bar was to weight into section. We saved that bar, we cut it up for posterity, we used it for our research and what have you. The second bar was a disaster. That was the last time, 15th round, 1 minute left to go in a fight, and we caught one in the nose. We ran the second bar. We had about halfway through the rolling sequence, the mill died. Just went black, went dark, like we lost power. So something like that happens. Sometimes it's good, sometimes it's bad. The good thing was all our safeties worked exactly as they should have, and they shut the complete mill down until we found a feedback circuit in our main drive motor that just happened to be wired backwards. We found one you know what, we didn't find in testing. We found it on the second bar. That set us back a bit in that we didn't have the confidence to just go back and go right into rolling again after we found that glitch. We went back into an in-place ghost rolling sequence where for, I think, about a day, we just ghost rolled without bars just to make sure that everything was working again the way it was supposed to. And I guess we did some little tuning in that period of time. But on the 18th day and the last shift of the 18th day, we rolled the third bar and it was perfect, and we sold it. And we sold product off the mill after that third bar as a normal efficient 59-inch mill, 48-inch mill, gray mill, whatever you want to call it. Our customers were happy. The customers saw no upsets in their orders because we had we were told 3 weeks. We told our customers 4 weeks. We did it in less than 3 weeks, so our customers were happy. That's our story on the 48-inch mill, 59-inch mill replacement. It was 35 or so years ago. I hope our memories were intact. If there's anybody that has another comment or another fact for this, I'd sure love to hear it.
Just a question, Larry. When you were ghost rolling that mill, did you come across any oopses like we could modify this or make changes or maybe something didn't work from the get-go?
Absolutely, absolutely, sure. You know, well, there were 2,000 I/O points on this mill. I/O points, I guess, for that. Describe pressure sensors, temperature sensors, speed tachometers, or what have you. Those types of deals. Nobody's going to wire and install and wire 2,000 points without some blips.
What about the mechanical end of it? Like the backing pieces and all that? You didn't have to modify anything?
During the ghost rolling, it would be safe to say, I could say, we installed what we made, what we designed. You know, and within the normal amount of oopses that you would find in any mechanical installation like this. We did have some upsets during our rolling practice, once we got up and rolling, that we didn't find until we had a little bit of repetitive history on the mill. And Mike, the one we talked about the other day, we had problems with the bar being fed to the mill. It would get so far and stop. Okay, we had a little bit of a gap here. It would just feed roll. We had to change this drive. We replaced that drive with a bigger drive. Mr. Bullock and I were talking this morning before we started. We had a couple of incidents with the big motor that required some maintenance and some study. Fortunately, we had the people in place to do that, and we had no Jim, we had no downtime, I don't think, associated with the flashing commutator. We had a fire, okay? There was a fire from the flashing commutator that got some insulation, caught fire. That kind of goofed us up for a little bit, but that was all, that was all in a normal rolling schedule. Yes, sir.
I came in late, so I'm not sure. I guess my question is, is this, you were producing heavy shapes, heavy structural shapes on this mill?
That's correct, sir. The 48-inch mill. The 48-inch mill rolled the biggest section by weight was the 14G. Was like Mike said, 730 pounds per foot. And the widest was the W36. And was that a 230? Was that the W36 230? Yeah.
300 pounds per foot.
300. Oh, okay. I'm sorry. Here. Yes, this is what we rolled. The 59-inch mill could roll the meter beam, which was a meter beam.
Well, the reason I ask, I was in the 1952 loop course a long time ago, and Bethlehem sent me on a training program, first to Pottstown plant, where in '57 I was working on the Walt Whitman Bridge. So you must have been sending shapes to Pottstown for us to fabricate on the Walt Whitman Bridge.
Absolutely.
That's true. Just about most of the product that was rolled on the mill went to some of Bethlehem's fab shops, Pottstown being one, Leesport was another one. They were all over the country. There was a couple of fab shops that existed here in the Bethlehem plant. Of course, the Golden Gate Bridge, Verrazano Narrows Bridge, some of the other bridges that these products went into.
This was the only Bethlehem plant to produce shapes?
They produced shapes at Lackawanna. In the late 20s, there was a gray mill, similar to there was a medium section mill, rolled the products in Lackawanna near Buffalo, New York.
Right.
Medium sections, not the heavyweights that were rolled on a 48-inch mill. The heavyweights and the large bridge beam sections were only rolled here.
Right. Well, the next job I had was sent to New York City, and we were putting together the Madison Square Garden, the round drum building, and that needed very heavy structural shapes. So I was just curious where all these shapes came from.
They went all over the country from this mill.
From this mill.
Yeah, yes, sir.
You mentioned the meter bar. We did roll with Spirit because of that mill. We were able to roll with a 39-inch mic. We rolled some. We thought out of that mill.
Yes, that's correct.
We called it a meter bill.
It
actually was 39 inches wide.
We used to call it 40-inch beam, but it was called a meter beam.
Right. I have another question. I missed the presentation. Did the presentation earlier include the plasticine lab we had on the mountain? Is that where I was a roller on the 48 and that 59. That's where we trained how to roll a book.
Well, Mahesh is here. Mahesh ran that
Yeah,
lab.
he was my teacher. Yeah. But the plastics, we had that.
Yeah.
Is that the same mill?
Oh yeah, 59.
That's it.
Well, not only that, we had lead modeling also. You probably came to that.
Which?
Mill rolling lead.
I don't remember that part. I remember the plasticine. I even got some plasticine at home that rolled.
Plasticine, we had a couple of mills, but then we purchased one mill to roll lead, just to support this mill. About 10 horsepower motor around a mill that we purchased. And Bill Wild, and myself and my technicians, we all worked on how to take this section pass by pass by pass for different section. That's exactly, you remember that, yeah.
Plasticine.
Correct.
It was like a Play-Doh kind of thing.
Exactly. The thing was the big thing in plasticine modeling mill, which I was in charge, but we also, just for this mill, went into lead modeling. So lead is easier to work with at the thinner sections. Plasticine is good for the blooming mill.
Yeah, I didn't get into that one.
Yeah, the plasticine is good for blooming mill, but the lead was good for finished sections. So that's what we did.
Can I ask a question?
Yes, sir.
How did it roll?
It had us up, it moved. It was faster. It sped up a lot of things, and it could roll bars got cold, it was able to adapt to that. And everything was like automatic. It was just automatic. You have to rely on, during the operation, you have to worry about operator error, missing its marks, stuff like that. The computer did all the designations of working in micrometers and micrometers.
Any other questions?
Yeah, Mike, where was the roll itself manufactured?
The roll
Yeah, all the components of the roll. Yeah.
Thank you, I did kind of skip over that. The mill was designed, the mill stand design was by Mannesmann Demag in Duisburg, Germany. In probably 85 when we cast these housings. Each housing side on the main mill, this house, this side, and that side, weighed 110 tons in the sand. We couldn't cast 110 tons in this country anymore in the 1980s. They were cast by the Hesch in the Hesch foundry in Duisburg, Germany, which was a kind of like a sister company to Mannesmann Demag. The rest of the mill components that you see here, except for the rolls. Rolls are made by us, right, Mike? I'm pretty sure we made the rolls. The rolls are made in Bethlehem, right? Correct. Yeah. Everything else in gray that you'll see from the pinion stands over were manufactured either in the Bethlehem plant or at the Birdsboro Corporation in Birdsboro, Pennsylvania, which had a U.S. license with Mannesmann Demag. Quite a bit of the equipment was built in Birdsboro, quite a bit was built here in the Bethlehem plant.
Another interesting factor where the motor came from the 35-inch mill and converted to the 59.
Almost right.
Oh, yeah, close to almost
I know.
right. Yeah.
No, the 35-inch mill motor was reinstalled on the 40 number 1 bloomer ahead of the 32-inch mill about 5 years before that.
Right.
Between the 40 number 1 and the 59, I aged.
What this gentleman is talking about is, for instance, when I started in 1965 in the mills, there were 8 steam engine driven mills. 3 on the 42, 3 on the 48, 1 on the 40 number 1, and 1 on another mill was a 28-inch mill, which was torn out 3 or 4 years later. A little tidbit on the electrification of the 40 number 1, I worked almost 2 days straight getting that mill ready to roll. And the last problem we had was attaching the spindle to the pinion stand with this pin, maybe 6 inches in diameter. We had to put it in dry ice because it was tight to try to get it to shrink a couple thousandths of an inch. And the young fellow that was on the sledgehammer trying to put this in didn't have the right technique. I grabbed the sledgehammer, and Bob Stockless was the foreman there. He'd mark it with chalk, and then I'd hit it a couple times, and we could see how it moved a fraction of an inch. And I kept pounding away at that thing for about 20, 30 minutes, so we finally got it in. And I told the roller 5 o'clock in the morning, call for an ingot. In the first hour, he broke the record for rolling ingots on the 40 number 1 inch mill because of the 5,000 horsepower DC motor that was put.
7,000.
7,000. Jim was the electrical engineer on that job.
Any other questions? I forgot to mention the motors are Westinghouse Electric DC motors that were made in Round Rock, Texas. Biggest motor they ever made in the 1980s. It might have been usurped over the last few years.
That's a question. What was during its most efficient, how many passes were decreased on the 46 bloomer and the 48 number 2? Because I heard that 48 2 was more or less a stamping, Bethlehem steel stamping, mill toward it was a finish. Yeah.
Yeah, the goal for the 59-inch mill was to make the number 2 stand one pass through. Okay, that was a goal. Sometimes we hit it, sometimes we didn't. That was temperature related and it was section related, and but it was never more than 3 passes, right?
Well, some were 5. Only because we ran.
Don't tell everybody.
The only reason was for straightening the bar. It wasn't for dimensions of the bar. It was just for straightening. That's all. We did a 1-pass section.
Any other questions? All right, that's, one more.
You mentioned there were 8 steam engines on the started.
Yeah.
And how many we had? 2 or more?
We ended up with 2.
2.
The
Blue Moore and
40-inch mill, the blooming mill,
last 2
and a 40 number 2 engines.
Just one more comment, if you want to enjoy the mill, play with this bottle, whatever. This model belongs to you. It doesn't belong to me. It belongs to Bethlehem Steel. Bethlehem Steel alumni. Thank you.
Yes, sir.
We don't have this facility anymore.
No.
If you wanted to get the product that you used to put out there, where the hell do you get it these days?
Nucor will make some of the product, the popular section. The bigger weights, you have to get them from Europe or Japan.
During the engineering study, before we started this project, we visited a few places overseas. There's a mill in Oviedo, Spain, that could roll the meter beam, and in Milazzo in Sicily. We visited those 2. They were Modernization DMAG mills. The roll change is Modernization DMAG patent, and those 2 mills that I just mentioned had this exact roll change system on there.